Welcome to today's webinar. On behalf of the Center for Occupational and Environmental Health, I'd like to welcome you to Work's Shifting Landscape, How Irregular Schedules Impact Health, presented by Jacqueline Ferguson. A few housekeeping items before we start. You'll be muted during this presentation. If you would like to ask a question, please enter it into the online chat or Q&A. We'll save time at the end of the presentation to address questions. When you exit the webinar, a link to the evaluation will become available in your browser. Attendees who have participated in the complete live webinar today with an attentive score of 85% or higher will be eligible to receive a certificate of completion. Once you complete the online evaluation, you will receive your certificate as a PDF via email within 1 week. Attentiveness scores are calculated by our webinar provider and are based on continuous engagement throughout the presentation. You will also receive a follow-up email with a link to the evaluation tomorrow on March 7th. This presentation is being recorded and will be made available on the Center for Occupational and Environmental Health YouTube page and our website, coeh.berkeley.edu. At this time, I'm pleased to welcome our presenter, Jacqueline Ferguson. She's a PhD candidate in the Division of Environmental Health Sciences at the School of Public Health, the University of California, Berkeley. Her dissertation involves developing quantitative metrics of shift work to estimate the association between exposure to rotational shift work and risk factors of metabolic disorders in an aluminum manufacturer's cohort. Prior to her doctoral studies, Jacqueline earned a Master's of Health Science in Environmental Health Sciences, as well as a Certificate in Risk Sciences and Public Policy from the Johns Hopkins Bloomberg School of Public Health. Thank you so much for joining us, Jacqueline.
Well, good afternoon, everybody. My name is Jackie Ferguson, and I'll be talking today about work's shifting landscape, in particular, how irregular schedules impact our health. So first, some learning objectives. On the completion of this webinar, participants will be able to define different types of shift work, describe best practices for measuring shift work exposure, become familiar with current hypotheses about how shift work impacts health, and understand the current shift work research. To do this, we're going to run through first a little bit of background on shift work, then look at some current perspectives on shift work and breast cancer, which will lend itself into the exposure misclassification of shift work and the best practices to measure shift work exposure. And then we'll look at an applied example of shift work domains using Time-Registry data, followed by a study of recent night and rotational work and the risk of incident hypertension. So to begin, what is shift work? Well, shift work is a type of successive work that involves irregular or non-standard work hours. Most people identify shift work as working the night shift, but it can be any work that occurs outside of standard working hours, which most define as working outside of 7 or 8 a.m. and 5 to 6 p.m. However, this can vary by country. So a brief history on shift work, which is now essential to our modern 24-hour society, has actually been utilized for decades. Scheduling work in shift systems was originally implemented for factory and assembly workplaces to operate longer than the hours feasible for an individual worker, therefore allowing the highest return to investment in terms of production. But today, shift work has expanded beyond the manufacturing industry to service industries and healthcare and food industries that can all be provided around the clock. While non-standard work schedules have been used for economic growth, they can negatively impact the economy as well through increased health expenditures, loss of productivity, absenteeism, presenteeism, and increased accidents at work. So workplaces have utilized shift work for decades. As a result, there are many different and highly customized work schedules that are considered shift work. Definitions in the literature include rotating shifts, weekend work, and various shift schedules that may or may not include night work. Although there are no uniform definitions that encompass all variants of shift work, estimates of the prevalence of shift work range up to nearly 20% of the US workforce. However, other estimates from the European Union in 2000 are much higher and state that only 25% of the population works exclusively on day shift, and the other 75% work on non-standard work schedules that may include permanent night shifts, permanent afternoon shifts, permanent morning shifts, or alternating combinations of all three. To date, there have been a number of studies examining the impact of shift work on human health. Aside from general malaise or the jet lag effect, which many of you have undoubtedly felt if you've traveled to the East Coast or to another country by plane, shift work has been linked to serious health effects. Most notably, shift work has been linked to breast cancer, cardiovascular disease, diabetes, and hypertension. More recent studies have started to make the connection of shift work and the negative impact it can have on gastrointestinal ulcers and cancers, as well as prostate cancer, metabolic syndrome, and even its impact on depression and anxiety. Every few days, another study regarding shift work and health is published, which often results in a continuous news coverage of the research progress. Just this week, an article was published that found higher rates of early menopause among nurses who carry out the night shift. So, how exactly does shift work impact your health? Most of the work examining the exact mechanisms for how shift work impacts health have been established using murine or other animal models. Through these laboratory studies, chronobiologists have established that both human and animal systems run on a 24-hour clock, a circadian rhythm, entrained by the movement of the sun. Environmental signals such as light and dark cycles provided by the sun, as well as temperature and feeding patterns, are called zeitgebers. If you've ever worried why you are hungry or sleepy at the same time of day, you can thank your circadian rhythm. Without getting too much into the science of chronobiology, we have a master clock in our brains called the suprachiasmatic nuclei, which is responsible for receiving the environmental signals, known as zeitgebers, and translating that information to the peripheral clocks found all across the body. Under normal conditions, this master clock will adjust the peripheral oscillators in our cells to the right phase within several days following a shift in local time due to traveling or shift work, for example. When your local clock is out of sync with the environment and your local clock has to reset or phase shift, this is called circadian rhythm disruption. We will all experience a minor form of circadian rhythm disruption this weekend on March 10th as we spring forward in time and add an hour to our clocks. While our bodies get used to this small phase shift, you may notice that you get hungry an hour later or find it hard to get up at the new time. Markers of circadian rhythm include core body temperature, secretion, and melatonin, as well as cortisol. So how does this translate to health? Repeat circadian rhythm disruptions alter normal cellular processes for a variable period of time, which subsequently influences other physiological conditions through numerous direct and indirect pathways, such as neuroendocrine stress and increased cortisol secretion. This can impact immune cell function, host defense, inflammation processes, and glucose tolerance, which then in turn result in intracellular and metabolic changes. These cellular changes culminate in a whole body adverse health effects, such as we see with breast cancer, hypertension, and disease. Circadian rhythm disruption may also extend sleep deprivation as the body tries to adjust to the new schedule, which may compound the effects of phase shift. Night and early morning shift workers sleep on average 1 to 2 fewer hours per night, which increases the risk of sleep deprivation based on self-reported data. As we see on the graph on the page here, shift work leads to phase shift, light at night and sleep disruption, and lifestyle disruption, which goes ahead and downstream effects your intercellular and metabolic changes. Ultimately, how shift work impacts health is outcome dependent. There's a specific hypothesis just for cancer outcomes known as the melatonin hypothesis. And melatonin is affectionately called the hormone of darkness because it's produced in dark conditions. It essentially helps regulate when your body sleeps and for how long it sleeps. Shift workers may be exposed to light during their biological night, which can interfere with the production of melatonin. Melatonin increases the expression of P53, a protein that helps keep cancer in check. Therefore, when melatonin levels are suppressed, tumor development may increase. The circadian rhythm hypothesis and melatonin hypothesis are the most commonly agreed upon biological pathways for how shift work directly impacts health. But there are a myriad of other variables that might act as confounders or effect modifiers of the shift work and health relationship. For example, individual characteristics such as your chronotype, which is your individual propensity for waking up or sleeping during the day or night. You might be a morning lark and find it easy to get up with the sun and work a morning shift without any issue. Or you might be a night owl who is most productive in the evenings and therefore doesn't mind the night shift. Or as we in the shift work research community like to joke, maybe you're a permanently exhausted pigeon if you're a graduate student studying shift work. But other factors can influence your individual tolerance for shift work as well, such as your age, gender, sleeping conditions, and even the amount of monetary compensation you receive for your work. All of these factors may influence your individual tolerance for shift work and therefore how your health is impacted. which complicates our epidemiological analyses. As I mentioned previously, there are a number of health outcomes that have been associated with shift work. One of the most prominent outcomes in current shift work research that has shaped the entire field is the study of breast cancer in shift work. So breast cancer was one of the first outcomes to be assessed in large human populations. And as a result of the studies produced from these analyses, in 2007, the International Agency for the Research on Cancer, IARC, concluded that shift work is a probable human carcinogen and gave it the ranking of 2A. This conclusion was based on sufficient evidence from animal experience, such as the murine models from leading chronobiologists. The conclusions were also based on limited evidence from 8 epidemiological studies on humans, the majority of which were from the Nurses' Health Study, a longitudinal follow-up of nurses all across the USA. The main hypothesis for how shift work caused breast cancer was based on the light at night causing a decrease in melatonin. This classification of shift work as a carcinogen dramatically shaped the way shift work was measured from 2007 forward. Following 2007, 18 new studies were published examining shift work and breast cancer. This effectively tripled the number of studies focusing on this issue and included 9 case control studies, 8 cohort studies, and 1 case cohort study. However, multiple meta-analyses resulted and some conflicted prior study conclusions. This resulted in news headlines such as, "Working at night is associated with a greater risk of breast cancer in women," followed by headlines such as, "Working night shifts are unlikely to increase breast cancer risk," followed by, "Women, take note, working night shifts may put you at an increased risk for breast cancer." And then, "Why has science seemingly changed its mind on night shifts and breast cancer?" And a lot of this was due to this paper put together by Dr. Ruth Travis, titled "Night Shift Work and Breast Cancer Incidence, 3 Prospective Studies and Meta-Analyses of Published Studies." Dr. Ruth Travis is a scientist at the University of Oxford and published this paper in the Journal of the National Cancer Institute. And this meta-analysis combined 1.4 million women together and analyzed the effects of shift work and breast cancer. Now, this particular study added 3 additional prospective studies, which were roughly 800,000 women from the Million Women study, an EPIC Oxford cohort, and the UK Biobank cohort, to 7 of the already published studies from the USA, China, Sweden, and the Netherlands. The study abstract concluded with, "The totality of the prospective evidence shows that night shift work, including long-term shift work, has little or no effect on breast cancer incidence." While the conclusion of the paper read, "The IARC 2007 shift work review was necessarily based on limited epidemiological evidence, and although further follow-up is desirable, the prospective evidence now available shows that the classification of night work as a probable human carcinogen is no longer justified," which is a strong conclusion to say the least, especially since it was based off of only one paper, or one meta-analysis. This sparked a bit of an academic contention, which progressed over several months as author comments were accepted and published. One response from Richard Stevens, an epidemiologist at the University of Connecticut, stated that the conclusions were not justified based on the new data or their meta-analyses. Joni Hansen, a shift work researcher from the Danish Cancer Society, stated that the short follow-up and the older population contributed towards the null findings. And my personal favorite from Eva Schirmhammer, one of the leading epidemiologists from the Brigham and Women's Hospital and the Harvard Medical School, who was the primary investigator of the Nurses' Health Studies examining shift work and breast cancer. She states, "Rejecting the possibility of night shift work as a potential carcinogen on the basis of a reported null finding between minimal exposure to night work and breast cancer risk in a very narrow time window during older age in one publication seems like bad science and tantamount to throwing the baby out with the bathwater." Overall, while highly entertaining for those of us involved in shift work research and contentious in the world of academia, it highlighted a few prominent issues with the assessment of shift work exposure. Namely, that the assessment of shift work is different in all of the studies, which would be contributing to the attenuated risk. Additionally, the short-term follow-up of aging cohorts lends itself to a truncated population of only the healthy workers, who are unlikely to have the outcome of interest as their susceptible coworkers were already lost to follow-up. This is where I became interested in studying shift work. The largest issue at hand seemed to be the potential for exposure misclassification. Shift work exposures are hard to capture due to their complexity. For example, how do you classify shift work? Is it night work? Is it a shift that occurs when the sun is down? What is the relevant exposure metric for shift work? Now, the Nurses' Health Study developed a questionnaire that asks, how many months did you work more than 3 night shifts while also working day shifts, intending to capture the population of nurses who are working rotational night shifts. However, as a result, their reference population, the group from which they're comparing all their risks to, and also the population that would answer no to this question, included both permanent day workers as well as nurses who are on the permanent night shift, as they didn't also work day shifts during their working history. So this question inherently combines 2 groups of people with very different exposures. Other studies asked, have you ever worked a rotational night shift? But found it difficult to ask the question often enough for high-dimensional shift work data while avoiding participant fatigue and high study costs. In response to the IR classification, a group of shift work researchers defined the potential domains to capture in epidemiological studies. These included defining the type of shift by its start time to estimate the phase shift or perturbation of your circadian rhythms. They also included terms to capture the intensity between shifts to approximate the recovery period after work. They also were interested in identifying whether a shift is rotating backwards or forwards, as it is easier to move forward in time. It's easier to travel to the West Coast and go to bed later than move backwards, which is flying to the East Coast and waking up earlier. But all these domains could not be captured in questionnaires realistically, and another source of data was needed. So this is where my research comes into play. My research examines these various shift work domains and incident risks for hypertension and diabetes using a rare source of granular administrative data from a large occupational cohort. The unique aspects of this study is that it uses daily working hours, data from time registries. That is, every punch in and punch out of a worker shift for their work history, like this time clock you see on the right side of the screen. These data sets were originally compiled to keep track of payroll, as the night shift or rotating shift schedules often come with extra pay. Now, the first aim of my dissertation was to develop and validate these metrics as we saw in the table prior, and create some definitions for what the heck is shift work. The idea was that others could then take these definitions and implement them, and we could reduce exposure misclassification in the field of shift work and health. So the study population that I was able to do this data analysis in is the American manufacturing cohort, which is an occupational cohort mainly composed of white male workers of relatively young age, developed by Dr. Mark Cullen at the Stanford University. These workers are all employed at the same company that is composed of light metal, refinery, fabrication, and manufacturing plants that operate on a 24-hour basis at relatively the same capacity and production scale. We also have access to their insurance claim information on this population because they were all enrolled on the same insurance plan. But the real gem of this cohort is the daily shift work data that was collected over 11 years using a time clock registry for payroll purposes, which gives us a tremendous amount of detail regarding different shift schedules. For example, in raw form, we have over 25 million observations of which each of them are a shift among 30,000 plus workers. This includes their meal breaks, their exact clock in and out times, sick days, vacation days. For the purposes of this analysis, we excluded shifts longer than 18 hours, which we felt corresponded to on-call shifts, and shifts shorter than 3 hours, which may correspond to on-site union meetings or not being needed for your shift that day. In short, this is a US-based cohort, and this level of granularity enables us to classify night work exposures in more detail than any previous survey data has allowed. So, to begin on this gargantuan task of understanding what shift work is, I structured the domains of shift work into 5 larger areas to capture. First, shift system. Whether that shift was a morning, a swing shift, an afternoon, evening, or a night shift. Second, schedule type. What type of rotational schedule the workers were on? Were they doing a permanent night work, or were they rotating between days and nights? Were they rotating in a slow or fast pattern, which would have implications for how often they experienced circadian rhythm disruptions? Additionally, was it a forward rotation, mornings, afternoons, nights, or backwards rotation, nights, afternoons, and mornings. As studies of airline pilots and flight attendants have revealed, workers have a preference for forward rotations as it's considered easier. 3, shift intensity. How many days off did they have to recover from a work week? Were they working shifts with less than an 8 or 11-hour break in between shifts? 4th, shift duration. How long were they working? As long shifts have been associated with an increase in workplace accidents. Finally, other domains to capture, such as call-in work and weekend work, which would impact the social jet lag a worker could have, which also might impact their circadian rhythms. For example, if you're working on a permanent night shift, you might not continue that same schedule on your day off. So even if you are a permanent night worker, you might actually be rotating back to a day shift to spend time with your family, literally a second shift. And this effect could be differential if your days off are on a weekend, where you're more likely to spend time with your family, or a weekday when maybe your family is at work or at school. So the first component I examined was shift type, which is best represented on a clock plot. Here we see the number of shifts for each hour of the day on a 24-hour clock plot. At the top of the circle is midnight, and at the bottom of the circle is 12 noon. The length of the bars corresponds to the relative frequency of each shift. As you can see from the large green bar between 6 and 7 a.m., the majority of shifts start at this time. However, there are 3 smaller peaks. First, the blue bars that start between 2 and 3 p.m., and the smaller purple bars that start at between 6 and 7 p.m. Finally, the pink bars that start between 10 and 11 p.m. So from this graph, we can see in this population, there are 4 discrete shifts. We can also look at this information stratified by plant location. In this histogram, the frequency of each shift start time is plotted against 24-hour time on the x-axis. I've demarcated in blue lines here, where the 6 a.m. mark is for ease of reading. In the first row, we have plants that are on a 2-shift system, essentially one that starts around 6 a.m. and a night shift that starts around 6 p.m. Each of them are about 12 hours long in order to cover the 24-hour plant cycle. The second row is comprised of a 3-shift system plant, those that have a morning, afternoon, and night shift, each about 8 hours long. The fourth row are the plants that I like to call my problem plants. These plants have both a 2-shift system and a 3-shift system operating at the same time, which is why there are 4 peaks. We can also examine how workers' schedules change across time, or how they rotate. And when we're trying to define how a worker might rotate, I went ahead and came up with a novel definition for what we would call a rotational shift. Now, the goal here is to characterize shifts that are most disruptive to people's circadian rhythms. So if you're considering a shift, maybe you normally start at 9 a.m., as seen on the clock on the right. Coming in a little bit later at noon, that's not likely to cause a shift in your circadian rhythms. Coming in at noon is most likely due to a doctor's appointment, or maybe childcare drop-off issues, or maybe you wanted to take a half day. But if we look at shifts that have a displacement in their start time of more than 6 hours that aren't on the same day, those are far more likely to be considered shifts that would cause a circadian rhythm disruption. So if you're working your regular 9 a.m. shift on one day, and then the next day you come in and work between 3 or 4 p.m., that's more likely to mess up your circadian rhythms. We can also add directions into this. So in yellow, I've gone ahead and demarcated what would be considered a forward rotation in time, moving from a shift at 9 a.m. to a shift over at 6 p.m. In green, we see the shifts that might be considered a backwards rotation. If you're starting work at 9 a.m. and then you're coming in for a shift that starts at 2 a.m., you're moving from morning into early morning, or what would be considered night. And these wedges in blue are the ones I find very interesting, because these are the flipped rotations. In these instances, there's no real direction to the rotation. It's just the inverse of your previous shift. You're going from working at a morning shift at 9 a.m. to working the night shift at 9 p.m. Your body isn't going to know whether you're moving forwards or backwards. It's just going to be the complete opposite. So we can look at the distribution of shifts with rotation by start times in this population. And at the top here, we see just what the start times are for shifts that are defined as being rotational. As you might expect, because we have a large number of shifts that start at 6 a.m., the majority of shifts that are considered a rotational shift start then. But we can break down the type of rotation to forward, backwards, and flipped. So first, forward, where shifts that start at 1500 or 3 p.m. are most likely to be categorized as rotations, as you see from the large blue wedges. Second, backwards rotations, where morning shifts were the most likely to be categorized as rotations, as seen by the green bars. And then the third plot shows the flipped rotations that tend to occur at either morning or night exclusively, essentially the 7 a.m. to 7 p.m. shift. So these complexities become important because a binary definition of a rotational night worker would encompass all three patterns of these rotations, which might obscure the effect that rotations has on the human body, because we'd be assuming that a forward, backwards, and flipped rotation are all the same. We can also examine what these patterns of rotations look like for individual workers. Here we have graphed 3 workers' histories of shift work over 4 years of follow-up. On the y-axis is the shift start time. On the x-axis, we have their follow-up time starting from January 1st, 2010, moving all the way through to January 1st, 2014. We have 3 workers represented on this graph. At the very top in green, it's a little hard to see because it's just pretty much a straight line around the 10:30 mark. We can see a permanent or always night worker. Every shift that this worker always works starts at around 10:30 p.m. for 4 straight years. In yellow, we have what would be considered as a traditional night worker. In the middle of 2010, when he just started working, he picked up that same night shift as our first worker. But then he switched to mornings and picked up a shift that started at 6:30 a.m. He did that shift for about 3 months here, and then switched right back to night work. There was a little bit of variability as he occasionally picked up a few shifts that started either 2-3 hours earlier, and once he came in very late at around 2:30 in the morning. But then eventually he just switched right back and worked that 10:30 p.m. shift for the rest of his history. In blue, we have my absolute favorite worker. In blue, we have what someone would consider generally a day worker. Now, this person generally works around 2 p.m., but has these fluctuations where sometimes they come in around 8 a.m., sometimes they come in around 6 p.m., but overall tends to work this regular schedule at 2 p.m. Around January 1st in 2011, this worker went ahead and tried night shifts and worked night shifts for about a month, that same night shift of that 10:30 p.m., and then went right back to working his 2 p.m. shifts. And then they have this very interesting rotation here, where they're rotating from the 2 p.m. shift to the 8 a.m. shift in these slow 6-month rotations. First working the 6 a.m. shift, then the 2 p.m. shift, then the 6 a.m. shift, and then the 2 p.m. shift. So this is something that we would consider a very slow rotation throughout time. So for a night worker, we can see that the general area where night work is defined is highlighted in green on this graph, and that the area that would be normally considered day work is highlighted kind of in this faint blue. And under these definitions of just night versus day work, we would see that that day worker is categorized as day worker. But you wouldn't be able to identify any of those rotations unless you split up and identify this as morning, evening work, and night work. Then you can see that this person is actually rotating between evening work, that 2 p.m. shift, to morning work, that 6 a.m. shift, alternatively every 6 months. The next thing I examined was the recovery or rest after shifts, which we define as a short return, which corresponds to having less than 11 hours between shifts. So the amount of time between your shift ending and your next shift starting is less than 11 hours, which would impact your ability to sleep, as well as get a variety of tasks that are supportive towards life, such as cooking, cleaning, child preparation, and things like that. So when we look at the number of short returns across time, we see that morning shifts are the most likely to have those short returns in this population, which means that they are working an evening or a night shift only to immediately come back with less than 11 hours and work the morning shift. But rather than examine one of these metrics at a time, some of the best insight comes when we can examine these different domains together. Like multi-chemical exposures, each of these domains, shift system, schedule type, intensity, and duration, may not operate independently. So what we've put together here is a joint distribution of the shift domains by the 4 shift types: morning, day, evening, and night shifts. In this population of over 25 million shifts and 300,000 workers, only 5% of the shifts were short duration. 5% of the shifts were morning shifts, while 50% were day shifts, 16% were evening, and 28% were night. Of the 5% of shifts that were of short duration, which corresponds to having less than 11 hours between shifts, most of them were night shifts. This is in contrast to our previous clock plot that gave the impression that day shifts were the most likely to be short returns. Day and night shifts were also the most likely to have weekend work as well, in addition to having more than 12 hours, which would correspond to a 2-shift cycle of night and day, each of 12 hours or more. But the evening shifts were more likely than day shifts to have more than 13 hours. This would match up with a regularly scheduled evening shift and then the worker picking up an additional 4 to 8 hours, basically picking up a half shift or a double in the morning. Here we see also the day shifts were most likely to be consecutive work days, which indicates that night shifts are more likely to work with days off in between. Forward rotations were more often evening shifts, while backward rotations were most often night shifts, which indicates a preference to move from day to evening and a preference to move from night to evening, as night to day would be a flipped shift as seen in the final row. But even if we can examine the distribution of these shift characteristics, if we're interested in human health outcomes, how do we apply it to people? Which leads us to the question, if we know that these shift domains vary by shift type, day, morning, evening, how might they vary by individual characteristics, such as age and race? So if we define people, a worker type, based off of the composition of their shifts, we can define them as permanent, day, morning, evening, or night, which would correspond to having less than 10 other shifts per year. Or we could define them as rotating day and night workers, for example, where they would have less than 10 evening shifts per year. Day-evening workers, which would have less than 10 night shifts per year, and so on and so forth. Here we see the distribution of person years among all shift workers. For example, females are more likely to be permanent day workers and night workers, while men were more likely to be day and night workers, as well as the 3 shift rotating workers of day, evening, and nights. We can also see differences by racial category as defined by the human resource records, where white workers were more likely to be permanent day compared with other race categories. We also see that Black and American Indian workers were more likely to be day-night rotators, while Asian or Pacific Islanders were more likely to be day and evening workers, indicating that the differences in shift work exposures are different by race, which may go on to confound the relationship between shift work and health. So unfortunately, or rather fortunately for my research, varying definitions of rotational shift work and night work is contributing towards exposure misclassification and may have been producing some attenuated effects. At this point, no one had really begun to implement the various domains of shift work that were identified by the IR classification of shift work. So what I went ahead and did was I leveraged some of these exposure variables that I just ran through and compiled them together to identify various domains of shift work and looked at the risk of incident hypertension. And we're interested in rotational shift work because there's been a number of studies that have associated it with an increased risk of, rotational shift has been associated with an increased risk of hypertension. And the reason for this is, once again, from the circadian rhythm disruption hypothesis. And we're interested in whether or not the change in work schedule is what's causing this increase in the risk of hypertension, the shifting from days to nights, nights to days, afternoons, mornings, etc. Or is it the working at night? So we're trying to pull out whether it's the night work itself or the switching between day and night work that is causing these increased risks in hypertension. And in particular, for this analysis, we were interested in the recent exposure. So not necessarily the exposures that occurred, over a decade ago, but in particular, those that had occurred within the previous year or the previous 12 months. So the population that we started with for this analysis was a subset of the largest shift work cohort, which was comprised of 2,151 of the blue-collar workers hired after the start of follow-up, which was 2003. Once again, they were mostly white men. They were aged 32 years of higher, and they were from 9 of these 24-hour manufacturing plants. We defined incident hypertension as a diagnosis code for hypertension on health insurance claims, and we used a 1-year washout for prevalent cases. So if a worker was diagnosed with hypertension within 1 year of starting their work, we assumed that they already probably had hypertension due to some other cause, or that the shift work exposure that they're experiencing now did not contribute towards the development of hypertension. So from these 2,151 workers, we found 215 cases of hypertension. And again, we use this daily exposure to shift work that was defined using this administration time payroll data, which was collected over the follow-up period. We excluded shifts shorter than 3 hours and longer than 18 hours because they either were too short or too long and represented on-call work. Here's some of the baseline characteristics of this population. We would see that there wasn't much of a difference between the amount of rotational work or night work that was done by both females and males. We could see a few differences by the amount of night work by race. A little bit of a difference between smoking status, where folks who were never smokers, current smokers, had higher rates of rotational work in the previous year. And then we saw a little bit of a difference, but not much by age. So we took these two metrics of rotational shift work and night work, and we put them in 2 models to examine incident hypertension. And we did this with a Cox proportional hazard model that controlled for age, sex, job grade, race, location, and health status, as well as their prior exposure. So for the model where we examined rotational shift work, we compared the workers with 1 to 10% night rotational shifts in the previous year, which is less than 3 rotations per month, on average to workers with 10 to 20% rotational work, which is between 3 and 6 times a month, to workers that work 20 to 30% rotational work, which is 6 to 9 times a month or 2 times a week, to those with the highest exposure, those workers with 30% rotational work, which is rotating about every 3rd shift. And what we see in this model is an immediate increase in the risk of hypertension with any exposure to shifts that had rotations. And furthermore, this risk increases even higher when we looked at those that were highest exposed. Now, these hazard ratios are higher, and the confidence intervals are large, indicating a little bit of variability in the data. But it indicates that there's something going on here with rotational shift works and incident hypertension. We also did this for night work, where we defined a night work or a night shift as a shift with at least 3 hours between midnight and 5 a.m., as other folks in shift work research have done. We compared folks that were only day workers against people with 0 to 5% night shift, which were people who did, occasionally 1 or 2 night shifts, those that were flipping back and forth very frequently, those 5 to 50% night shifts, those with 50 to 95% night shifts, and then those 95 to 100% night shifts, those who were virtually permanent night workers. And what we see here is immediately upon doing, 0 to 5, a little bit more than 0 to 5% night shifts, we see a hazard ratio of 2.3, which is indicating that doing just a little bit of night work is roughly doubling the amount, or you're doubling your risk of incident hypertension compared to day workers. Also interesting in this was those workers that had 95 to 100% night shifts had almost a 4 times higher risk of incident hypertension. Now, this was a little bit different than what previous studies had seen. Usually they see an attenuation of an effect among the permanent night workers, but here we saw the highest risk, which indicates that these workers might be rotating back to day shifts on their day off, for example, when they're hanging out with their families, so that these workers might be rotating. So what we did next was we combined both these metrics together. We looked at night work and rotations in a categorical combination. So we looked at people who did non-night work, essentially day work. We looked at people who did mostly night work and infrequent rotations. We looked at people that did mostly non-night work and frequent, mostly night work and infrequent rotations, and then mostly night work and frequent rotations, essentially our highest exposed. And there we saw that compared to non-night workers, hazards were increasing among workers with any recent night work. So among workers who are mostly non-night with infrequent rotations, the hazard ratios were 2.8 with a confidence interval of 0.97 to 4.87 compared to non-night workers. Whereas workers with mostly night work and frequent rotational work exposure were at the highest risk with almost a 4 times higher risk of hypertension. Now, these estimated risks of hypertension in the study of mine were higher than previous research. And we have a few ideas for why that might be. We focused on a shorter and more proximate window of exposure. We looked at the previous 12 months, whereas other studies such as Morikawa, Saka, Oshii, Cheng, Hublin, Liu, and Kubo looked at shift work in windows between 2 to 5 years ago, 5 to 10, 10 to 20, and greater than 20 years prior. Some of these studies didn't specify the exposure period at all. So if the biologically relevant window of exposure for development of hypertension is a year, then we would expect our study to report higher risks than others. Additionally, these studies may have estimated lower risk due to binary definitions of shift work, such as ever or current versus never night work, or classifying them as rotating shifts versus not. So we might have detected a higher effect because it's there and we didn't have as much exposure misclassification. That said, our confidence intervals were quite large, and we're looking forward to reproducing this amongst a larger cohort of people. So what's next? Our study results indicate that recent rotational work and night work may be associated with higher rates of incident hypertension. However, more shift work research using detailed measures of shift work exposure sourced from objective Time-Registry data is needed. Additionally, more studies are needed to examine the exposure-response relationship of cancer. However, we weren't able to examine this in our cohort as our workers were exposed to shift work from 2003 to 2014. So we didn't have quite enough follow-up to assess the incidence of cancer, which can occur over a period of decades. So conclusions. Main hypotheses for how shift work impacts health are through melatonin production and circadian rhythm disruption. Different types of shift work can capture different biological effects. For example, the impact of working a night shift as a permanent worker versus doing rotational shifts versus working long shifts or any of the combinations in between. The best shift work exposure data comes from Time-Registry data, as we can kind of collect this information without any burden on the workers. And we're already using detailed systems that are implemented for finances, so they have a high reliability of being accurate. However, questionnaires are still very good because they're able to capture individual characteristics and other confounders, such as diet, exercise, a number of children, this type of information that may not be captured in these administration records. Finally, exposure misclassification of shift work might be attenuating measures of association towards the null. And in order to really figure out if there are these relationships between breast cancer, hypertension, diabetes, and shift work, we really should strive to have uniform exposure definitions of shift work that reduce the amount of misclassification as small as possible. So to wrap up, I have no conflict of interest. I would like to thank the Center for Occupational and Environmental Health and the School of Berkeley Public Health for supporting me. A special thank you to Ellen Eisen, Sadie Costello, Mark Cullen, Andreas Neofitu, John Balms, Patrick Bradshaw, and Sally Pichotto, who have listened to me bother them endlessly with questions or have served on my dissertation committee. And then finally, some funding sources. I am funded by the NIH as well as NIOSH. And with that, I would love to take any questions, and there's my contact information on this screen if you want to go ahead and follow up via email.
Excellent. Well, thank you so much for describing your research to us, Jacqueline. We really appreciate it. At this time, I would love to open it up to questions. All of you in attendance out there, you can enter any questions that you have into the online webinar chat. You can also enter it via the Q&A box. And as we're waiting for some questions from our audience to roll in, I wanted to also just revisit the strengths and weaknesses of data set and see if you could talk a little bit to why you decided, again, you chose this cohort specifically. What are some of the weaknesses involved in choosing that cohort, and also the strengths of choosing that cohort? And if in a perfect world, if you could have had any data that you wanted, what would you have liked to see?
Of course. Well, I guess first, this cohort kind of chose me. This was my third dissertation topic, and this one happened to have enough people to follow up on the question I wanted to answer. In terms of the perfect cohort, obviously this cohort is limited because it's looking at a blue-collar workforce of manufacturing workers. If you can imagine, these are big, burly white men of a certain age with kind of like beer bellies, capable of working in incredibly hot temperatures. So this is a very unique type of shift work, which may not always match up with, the nurses from the Nurses' Health Study. The perfect study, the Danish and the Finnish, the Scandinavians essentially, are getting very close to this, where they have shift work for almost their entire country. And they have register data on their insurance, their follow-up, their taxes, literally from birth to death or emigration. So ideally, I would love, the entire U.S. to have information on, so that we could really get a variety of different jobs and different types of shift work. But I feel if I actually had that, I would never, ever graduate.
Wonderful. Thanks so much. That's great. We do have a couple of questions that have come in. One is, what is the best way to optimize health given the necessity of shift work? For example, advertisements to workers, some like the standard shift due to commuting, etc. Is there any sort of advertisement or communication you think is appropriate for managers as they're doing shift scheduling?
Yeah, so I think shift work is never going to go away, particularly because we have this fascination with getting everything we want 24 hours. So even if you're looking at retail or food, I don't think that's ever going to close. Eventually, maybe it will with, the rise of robots. But to get to the question of, what we can do to help workers now, I tend to think of it in terms of like ergonomics or car safety. Shift work exists, but maybe if you're prone to hypertension already, you have another risk factor due to your genetic background or family history, maybe we should be encouraging those workers to not work the night shift, or if they have to due to financial constraints, try not to work rotational shifts or flip back and forth as often. So much in the same way that we have seatbelts in cars to mitigate risk, or we tell people to use sit-stand desks for ergonomics, maybe we can help reduce the risk for shift work because we can't completely remove it right now.
Great, thank you. We have another question asking about the nurse cohort, mainly women, if they show any difference with the manufacturing cohort of mostly men.
Yeah, so the Nurses Health Study does detect, hazard ratios for hypertension and breast cancer around 2, comparing their women. It's a little hard. You're comparing men to women, apples to oranges, right? There are different biological effects going on there. Most notably for the Nurses Health Study, their definition of shift work is that rotational shift work while working days, which is different than the definition I've implemented, which is comparing just day workers to night workers and varying scales of night work. In the paper I published in the Scandinavian Journal of Work Environment and Health, which is where all those results for hypertension came from, there is an additional table where I did apply the same definitions from the Nurses Health Study and still detected, although attenuated compared to the original definition for rotational shift work, an effect for hypertension.
Thank you. We have a compliment. This was an excellent presentation.
Thank you.
And after the completion of this research, will it be possible to track these individuals long-term to find out their hypertension status?
We are working on ways to tie this information into other administration systems that are already implemented in the US. For example, we can track these workers once they reach Medicare, Medi-Cal after a certain age, and we can track some of their W-2s and things along those lines, but it's very tenuous. We tend to lose, for example, women as they change their last name when they get married. So it's hard, but we're working on tying this information to other existing cohorts that we could follow these workers, such as national cancer registries as well.
Great, thank you. Another question, was the family HX of HTN taken under consideration as a part of the cohort?
The family I'm sorry, I didn't catch that.
Yes, and perhaps the person who entered this question, if you could extrapolate on the HX and HTN acronyms, was family HX.
It's probably family history of hypertension. I'm going to go ahead and hazard a guess.
Okay, great.
No, unfortunately, it wasn't. We didn't have any records for family history, which is one of the limitations of this cohort. The information we have is really on the workers, and occasionally the family members who are listed as co-beneficiaries on their insurance, but overall, no family history, which is unfortunately might be biasing some of our results.
Thank you. We have another question also related to the effect of different lighting. For example, alternate types of lighting sources and how that might affect blood pressure. And was that considered at all as a co-founder?
We do, and there are some interesting studies that examine the impact of blue light at work. We unfortunately don't have a measure for the light exposure that these workers had during their either biological night when they're sleeping at their houses or at the manufacturing plants. I can tell you that these plants do operate 24 hours at near high capacity, full capacity. So it's not like working the night shift as a nurse where the lights might be dimmed to help patients sleep. And among those, there have been other studies that have looked at taking workers' home addresses and using geospatial analysis to look at the light detected from space to kind of approximate the amount of light at night. So there's some interesting work going on with that, but unfortunately we have not encountered that information for these workers.
Excellent. Well, thank you so much for your time today, Jacqueline. We so appreciate it. And also thank you to everyone who joined us for today's webinar. COEH hosts webinars the first Wednesday of every month from 12 p.m. to 1 p.m. Pacific. Next month, we're going to be joined by Kurt Walling, who will be presenting on active shooter awareness training for schools. We've also launched a new ergonomics webinar series in cooperation with NIOSH education and research centers throughout the entire country. These webinars are taking place the third Wednesday of each month. On March 20th, we'll be joined by Carissa Harris, Director of the UCSF UCB Ergonomics Research and Graduate Training Program and Deputy Director of the Northern California Center for Occupational Environmental Health. We'll be presenting on California's new standard for reducing musculoskeletal disorders among hotel room cleaners. Be sure to check out our website for more information and to register. You can find us at coeh.berkeley.edu. And as a reminder, as you leave the webinar today, an evaluation will pop up in your browser. If you have attended the full webinar today and you had an attentive score of over 85%, you are eligible to get a certificate of completion from us once you complete that evaluation. Thank you again so much for joining us, and I hope you all have a wonderful day.